Welcome to the Network Plus Prepcast, your dedicated audio companion for mastering every objective on the CompTIA Network Plus certification exam. This series is produced by baremetalcyber.com. Growing on Demand focuses on two fundamental concepts that define the flexibility and responsiveness of cloud computing environments. Elasticity and scalability enable networks, servers, storage, and applications to grow or shrink in alignment with demand. These traits reduce waste, improve performance under load, and allow organizations to adapt quickly to changing conditions. They are critical to cloud-native architecture, where services must be available, cost-efficient, and capable of expanding without disruption. The Network Plus exam includes elasticity and scalability under cloud architecture and resource management objectives. You may encounter questions that ask you to differentiate between these two terms, interpret automation triggers, or select the appropriate growth method based on a given workload. These topics often appear in scenario-based questions that test your understanding of cloud behaviors and deployment strategies. Being familiar with both terms and their relationship to automation and performance is essential for passing questions in this category. Elasticity refers to the ability of a system to automatically adjust its resources in response to real-time demand. When usage increases, resources expand. When usage drops, resources contract. This automatic adjustment happens without human intervention, making it ideal for applications that experience variable loads. Elastic systems reduce operational burden and ensure responsiveness during traffic spikes. Elasticity is a hallmark of public cloud environments, where workloads fluctuate throughout the day or across seasons. Elastic systems offer a variety of benefits that make them attractive for modern deployments. They allow organizations to handle peak loads without the need to permanently allocate large amounts of hardware. This leads to significant cost savings, as resources are not sitting idle during low-demand periods. Elastic systems also enhance user experience by maintaining responsiveness during periods of high activity. Whether handling thousands of user logins or managing background processes, an elastic environment ensures consistent performance. While elasticity and scalability are closely related, they are not the same. Scalability refers to a system's ability to grow or expand its capacity to handle increased demand. Elasticity, on the other hand, describes the dynamic use of that scalability. In other words, a scalable system can be manually expanded, while an elastic system does it automatically. Elasticity is a dynamic form of scalability, where adjustments happen in real time based on triggers and thresholds. The exam often asks you to compare these terms directly, so understanding the distinction is critical. There are two major types of scaling, vertical and horizontal. Vertical scaling involves increasing the resources of an existing system, such as adding more memory or CPU to a single virtual machine. Horizontal scaling involves adding more instances of a system, like spinning up additional web servers. Vertical scaling is often limited by hardware constraints, while horizontal scaling is more flexible and fault-tolerant. Each method suits different applications depending on whether they support parallelism and distributed processing. Scaling decisions are driven by specific metrics and triggers. Common scaling triggers include CPU usage, memory consumption, disk I/O, and the number of incoming requests. Monitoring tools continuously collect these metrics and feed them into automation systems that initiate scale-up or scale-down actions. In some cases, scaling may also be time-based, with resources scheduled to expand during business hours and shrink after hours. Threshold-based scaling is more dynamic and responds directly to real-time performance data. Auto-scaling groups are built-in features of cloud platforms like AWS and Azure that automatically add or remove instances based on predefined rules. These groups are linked to health checks and load balancers, ensuring that only healthy instances receive traffic. If one instance fails, it can be replaced automatically. If demand increases, more instances are launched to maintain performance. Auto-scaling groups reduce manual intervention and support consistent service delivery across different workloads and environments. Scalability must be considered during application design. Stateless applications scale more easily because they do not rely on local session data or persistent connections. This allows them to be replicated across multiple nodes and served through a load balancer. Load balancing distributes incoming traffic evenly, ensuring no single instance is overwhelmed. Storage systems and databases must also be designed to scale, either through replication, partitioning, or distributed file system. A scalable design supports elasticity by making it easier for the system to respond to growth events. Resource pooling is another critical aspect of elastic and scalable systems. In cloud environments, resources such as compute, memory, and storage are drawn from shared pools. These pools allow cloud providers to allocate resources dynamically across tenants and workloads. When demand spikes, more resources can be allocated from the pool. Tenants may be logically isolated within these pools to prevent interference. Resource pooling ensures high utilization and availability, supporting growth without requiring physical changes to infrastructure. Scaling in hybrid environments presents additional challenges. On-premises, systems are typically slower to scale because they depend on physical hardware and manual processes. However, organizations can extend their on-prem infrastructure with cloud-based resources to create hybrid burst scenarios. In these models, local resources handle baseline workloads, and the cloud absorbs overflow during spikes. This hybrid strategy supports elasticity without requiring a complete migration and offers flexibility during transitional phases or seasonal demand shifts. For more cyber content and books, please check out cyberauthor.me. Also, there are other podcasts on cybersecurity and more at baremetalcyber.com. Monitoring tools play a crucial role in making informed scaling decisions in elastic and scalable environments. Services like CloudWatch in AWS, Azure Monitor in Microsoft's cloud, and various third-party platforms provide real-time metrics about system performance. These tools collect data on CPU usage, memory consumption, network throughput, and user requests. Based on this data, alarms can be configured to trigger scaling actions. When a metric crosses a certain threshold, an automation rule launches new resources or shuts down unneeded ones. This real-time visibility is essential for keeping infrastructure responsive and cost-efficient. Storage and database systems must also be designed to scale effectively. This can involve techniques like sharding, where data is split across multiple systems, or partitioning, where data is separated by category or time range. Replication can be used to create multiple copies of data across different servers, which supports both read scalability and fault tolerance. Many managed database services in the cloud handle these scaling operations automatically, adjusting capacity based on workload and usage patterns. This automation reduces the administrative overhead and improves service availability. Licensing and cost considerations are important when implementing elastic or scalable architectures. Elastic infrastructure helps reduce fixed costs because you only pay for what you use. However, scalability can impact licensing tiers, especially if software costs are based on CPU cores, memory size, or instance count. Unexpected traffic spikes can lead to sudden cost increases if scaling is not properly controlled. Monitoring tools should be configured to alert teams when costs deviate from normal patterns, and budget thresholds can be enforced using billing alerts and resource quotas. Avoiding over-provisioning is one of the primary benefits of elastic systems. Traditional environments often reserve more resources than necessary to account for peak demand, resulting in idle capacity. Elastic systems allow you to match resources closely to actual usage, minimizing waste. Historical usage data can be analyzed to create right-sizing strategies, ensuring that each layer of the system has exactly the resources it needs. No more and no less. This approach supports sustainability, lowers operational costs, and enhances the efficiency of cloud infrastructure. Rapid scaling introduces its own set of risks if not carefully managed. When new instances are launched, they may require bootstrapping scripts, software installation, or configuration before they can serve traffic. If this process takes too long, users may experience delays. Misconfigured load balancers can route traffic to instances before they are ready, creating errors. Auto-scaling loops can also occur if thresholds are too sensitive or if there is no cooldown period between scale actions. These risks can be mitigated by tuning thresholds, scripting efficient boot processes, and enforcing cooldown timers. Manual and automated scaling each have their place in cloud architecture. Manual scaling requires human intervention and is typically used in more stable or predictable environments. It provides full control but lacks responsiveness. Automated scaling responds in real time to system metrics and can react faster to unexpected traffic changes. Hybrid strategies are often the most effective, combining scheduled manual actions with automation to cover both known patterns and unforeseen events. This balance ensures flexibility and resilience while maintaining cost and performance goals. Security remains a critical concern during scaling events. New instances must be launched with secure configurations from the start. This includes applying firewall rules, installing endpoint protection, and enabling monitoring agents. Auto-deploy scripts should include security validation steps to ensure compliance with organizational standards. Role-based access must be enforced to prevent unauthorized changes during scaling operations. Additionally, logs from new instances should be collected and reviewed just like those from existing systems to maintain visibility and auditability. The Network Plus exam covers elasticity and scalability by asking candidates to define these terms, compare their characteristics, and apply them to real-world scenarios. You may be asked to recognize which cloud features enable elasticity, explain how auto-scaling triggers work, or evaluate the risks of scaling without automation. Questions may also involve selecting the appropriate scaling strategy for a given application, or identifying monitoring tools that support performance-based scaling decisions. A thorough understanding of these concepts is essential for mastering cloud architecture topics on the exam. Elasticity and scalability are two pillars of cloud net infrastructure. Elasticity provides the ability to grow and shrink resources automatically in response to real-time demand. Scalability supports the overall capacity to grow as needs increase. Together, they form the basis of efficient, flexible, and cost-effective cloud environments. By understanding the tools, behaviors, and challenges associated with these models, you can design systems that perform well under pressure, adapt to changing workloads, and deliver consistent service across all usage levels. Thank you for listening to this episode of the Network Plus Prepcast, your trusted audio guide to the CompTIA Network Plus certification. This episode was produced by baremetalcyber.com. For more cybersecurity podcasts, books, and resources, visit baremetalcyber.com. Thanks for joining us for this episode of the Bare Metal Cybersecurity Plus podcast. For more episodes, tools, and study support, visit us at baremetalcyber.com. And before you take the test, make sure to check out the practice questions in the book Achieve CompTIA Security Plus SY0-701 Exam Success by Dr. Jason Edwards. They cover every domain and are a powerful way to lock in your knowledge.